Okay, so let's start with the discussion. Hopefully. Okay, just give me a moment. I will have to join back. Give me just 1 minute. Thank you. Uh, about this interruption, um, my accessories were not working on the laptop, so I had to restart it. Okay, so welcome to today's session. Today we are going to talk about a very high level introduction to um, a set of technologies combined known as AWS DevOps, or sometimes also known as developer tools, right? So what are the tools available for developers to develop and deploy their applications? Okay, before we start, my name is Amit, and I've been in the industry for 18.5 years now, and I have worked across the entire domain of DevOps, so CI, CD, deployments, containers, IAC, configuration management, everything I have worked on, right? So today I'm just going to share my understanding of AWS developer tools, right? Before I start, it's going to be a very concise discussion. So I'm going to speak for around 45 minutes, and then we'll spend some 5 minutes for Q&A. Please try to restrict your questions to the topic here, and also try to hold on the questions till the end of the discussion. Also, please do not ask the questions on the chat. You should ask the questions on the Q&A section. Okay. Couple of people have mentioned that they can't hear me. Is my voice okay for everyone? Is it loud enough, clear enough? Okay, cool. All right. So AWS developer tools, right? Why do we need those tools? Before understanding about AWS developer tools, we need to understand about what is a development process, right? So if you talk about software development process, it combines, and we are actually talking about the implementation. So, there are various stages in software development. Starts with planning, and then, budgeting, team formation, and then architecture designing, which is the design document. And then finally, when everything is ready, software engineers come into picture and start developing the product, right? And that's called implementation. And this developer tools actually plays important role in that phase of software development, right? So there are developers who write the code. There are testers or verification engineers who test the code. And then there are, I would say, DevOps engineers, or, you can also call them maybe ops, or you can call them SRE or whatever. And these guys are responsible for deployment of the application that is developed by developers and tested by testers, right? So the developers write piece of code, the testers verify that piece of code or the application that does it work according to customer requirement. And once that is done, the DevOps engineers or the operations people, they actually uh, run the application and execute it, right? So this is the complete developer workflow. And after this is done, there are other processes, for example, maintenance and sustenance and things like that. That is out of developer scope, right? similar to the previous steps, which is designing and requirement gathering and all that, which is out of developer scope, right? So during the implementation, the team may use developer tools. Now, why do we need the tools, right? We need the tools to collaborate, right? To develop faster. So to be faster in development and deployment both, right? And for collaboration, for development, faster deployment, then early feedback about the test results and the feature status and all that. So these all things are enabled by developer tools, and you can quickly, if you are aware of the term DevOps, you can quickly associate that, hey, these are the benefits of following the DevOps practices, right? So you do CI, CD, or continuous testing, continuous monitoring, things like that. So if you implement these technologies, you can collaborate using a version control system like Git. You can develop faster, right? So you can use CI and CD principles. So CI for faster development and CD for faster deployment. Early feedback is again, culmination of all these technologies. So each developer, when they make change, they get a quick feedback that their code is fine and it's not breaking this entire product, right? So you achieve all these things. And in non-AWS environments, or I would say non-cloud environment, we already know various tools that helps us in that, right? I have already mentioned Git for version control or for code collaboration. You also have Jenkins, right? Jenkins, you have distributed Jenkins where you can add multiple nodes. You have Jenkins pipelines, right? So these are a couple of tools. Then you have other tools which help you in achieving delivery and deployment of your project. So for example, Docker, maybe you can deploy it on Kubernetes environment and things like that, right? So now these tools, especially the first one and the second one, are pretty cloud agnostic, right? They can work anywhere. They can work on your on-premise data center. They can work on AWS. They can work on Azure. But then if you work on cloud or specific cloud providers like Azure or GCP or AWS, using these tools becomes a challenge because these are not optimized for those environments. So although you can, in your AWS account, you can spin off a virtual machine or an EC2 instance and then install Jenkins on that and then perform your CI/CD operations. But that setup does not make use of AWS technologies, underlying technologies. It does not integrate out of the box to other AWS technologies. So to make most out of, for example, AWS technologies, we make use of the developer tools provided by them, right? And that's why we are learning AWS developer tools. What are those tools? How do they help us and how do they enable us to do a CI/CD in AWS environment, right? Now, again, using AWS developer tools is completely optional. If you are using AWS environment, you may or may not choose to use AWS developer tools, which is perfectly fine. You can still live with Jenkins or any other CI technology or GitLab CI or GitHub CI, right? But it's one of the options. So let's explore what are those options. Let me first of all take you through what are the options that we have. Give me a sec. Right. Let me sign into my AWS account. Give me a second. All right, I'm signed in. So this is my AWS account. And if I click on services, you can see a hell lot of services here. right? Services for blockchain, services for compute, which is pretty popular. We have EC2 instances and everything around there. We have container services, so EKS, ECS, ECR, everything is there. Database services. And similarly, we have developer tools, right? Developer tools is nothing but a set of services provided by AWS to enable developers to develop faster, develop with high quality, and deliver and deploy faster, right? So you can see app config, Cloud9, Cloud Shell, code artifact, and things like that. So I'm not going to talk about all these services. I'll just pick up maybe 4 services and then talk about those there. So there is CodeCommit, right? Let's open in a new tab. Then there is CodeBuild, right? I'm going to open it in a new tab. And then there is code artifact as well. So open it in a new tab. CodePipeline. I'm going to talk about that as well. We can talk about Cloud9, right? Yeah, for now that is enough. Okay. So first let's talk about CodeCommit. Okay. Now CodeCommit is nothing but a Git service. Like you have GitHub where you can store your source code. Similarly, you have CodeCommit where you can store your source code. The advantage of using CodeCommit is it is fully managed by AWS, and you can use your AWS policies and users and accounts to access or configure the access to this repository. While in GitHub or GitLab, you have to manage the permissions separately, right? So this is CodeCommit, and you can create repositories and put your repositories there, right? So if you want to use Git on AWS, you use CodeCommit, right? Then comes Jenkins. Jenkins has a lot of options. Like when you use a pipeline, you can build, right? You can test, you can generate artifacts, right? Publish artifacts and things like that. So in developer tools, we have different components which achieve this. For example, there is something called as build project or code build, right? Code build is nothing but a CI tool or CI service. You can write a series of steps to be executed on your source code, and maybe you want to run some compilation or you want to run some tests or unit tests, whatever you want to do, you can define those steps and that will be executed on the source code, and then you can publish the log of it, or you can deploy the code somewhere, right? If your code generates some artifact, for example, if you have a Java based project and your code build commands have, for example, Maven package, which generates a jar file or a war file, then you want to preserve those, and those can be done using artifacts, right? It's nothing but the artifacts are nothing but the generated tangible outcomes of your build, for example, your logs or your exes or your binaries. So how do you manage your artifacts? That is done using AWS code artifacts. Okay. Now, these are all individual things. You have code commit, you have code artifact, code builds, and you also have code deploy, right? So if I click here, this is your code deploy. Just give me a second. Let's go to deploy and here, right? So this is your code deploy. You can see here, they are all visible in the same subsection called developer tools. So your code commit is also under developer tools, deployments, artifacts. And then finally, there is something called as pipelines, right? Pipelines. What are pipelines? Pipelines are nothing but interrelated sequence of various steps that you want to execute, where your source code is subjected to various checks and processes as part of a particular sequence of actions, right? For example, if you write a source code, you may want to perform linting test or static code analysis on your source code. Then you want to compile, right? Then you want to create artifacts, and then you want to maybe deploy them. Yeah. So those are various steps, and those individual steps are achieved by these individual tools. You can have your source code here. You can run your source code static code analysis and your packaging and your test in the build. Your package outputs can go in the artifacts, and then finally you can deploy those outputs on some deployment environment, right? These four tools, just give me a second. Yeah. So these four tools, they allow you to perform all these operations, but they perform the operations in isolation, right? If you write some tests on code deploy, they will execute, but they can't do anything more. Okay. So how do you make them interrelated? You make them interrelated by putting them together as part of a pipeline, right? Different phases in the pipeline, which can be achieved by these individual tools. Make sense? Right. So now let's take a look at some of these technologies. I may not be able to cover all of them because we have only some amount of time. So let's start with CodeCommit, right? A CodeCommit is, if you want to read more about CodeCommit, you can click on this Get Started button, and this explains to you what is CodeCommit, right? In a nutshell, it's a service where you can put your source code or your Git repositories. All right. So let's quickly, if you click on repositories, you can see your repositories here. Right now, there are no repositories, so you can create one. For example, I create a repository called Skill Upright Demo, right? And I can give some description. Example repository, and you can add some tags or something. But yeah, let's leave it away. You can also enable Code Guru, where it can do a code review automatically on the source code, but I don't want to enable that. So I just click on give these two details and click on create. And it shows us this information, right? Um, Now, what does this mean? This means that a repository is created, but it's an empty repository. It does not have anything here. So you have to populate this repository, right? So if I go to repositories now, you see Skill Upright Demo. If you select it, you can see more details here. For example, you can either delete it or view the details, or you can also get the clone URL. So you can clone the repository using SSH, for example. So this is a command for SSH, but for that you have to upload the SSH keys. So you can add SSH keys as well. Or to make the life easy, you can also clone it using HTTPS by your username password. Okay, so let's populate some source code here, maybe a little couple of files, and then see what it does. I'm going to open my terminal. And here, let's click on the clone URL and get the HTTPS URL. Or I can just click on this button to clone this URL here. Right? I copied it. Let's see. I say git clone. I assume you have already worked with clone git or git commands before, so you know what I'm doing here. If not, then you can learn about it later in your own time, what is git and how it works. And I can just give this copied command here. Press enter. And now it says, give us username password, right? I can try to give username password, but let's see. Just give me a second. I'm trying to retrieve my password. Give me a sec, please. Okay, so that username password didn't work, right? Fine, that is fine. So let's go into the repository. And then you also have a little bit of help provided by AWS, right? So you must have a Git client installed, okay? And you need to have AWS CLI credential helper, right? So let's do here. I think AWS has changed a little bit. So, or there is another way that you can add or upload file here or create a new file directly in the repository. Okay, but we'll come back to that later. So let's do one thing. Let's create an AWS user, right? Let's go to from here. Let's go to IAM. And there is users. So I'm going to create a user and call it as dev, right? Let's call this user as dev, and then click on next, right? And I can attach policies directly. So I can attach some policy here. And to be able to access our CodeCommit repository, right? You can assign these policies. There you go, right? And click on next. And I create this user. So I have a user called dev now. Okay. And I disable the console access. Just give me a second. So I go to security credentials, right? And I can upload an SSH public key here. So I can actually generate credentials here, you can see. So let's go to the beginning. If I go to the users, I can create a user, and then I go to dev. And if I go to security credentials, now, since I attached the Git policies, right, I can set HTTPS Git credentials, right? So I can generate those, or I can upload an SSH key as well to work with SSH, right? Both of these are possible right now, right? But let's try with credentials, okay? For now, I click on generate credentials, and it generated a username here. So I copy it, and I'm going to maybe use the credential manager. So like this. So I copy the username. Okay, hold on a sec. Yeah, I cannot. Right. So this is the screen, right? And this is the password that it generated for me. It's a random password. So I need to preserve it. This password, I cannot see it again, right? So either I can download the credentials or just copy it and preserve it. Let me just download it just to be sure. So you see a CSV is downloaded here. I close it now. So I have the username, and now I have the password. I save them here. And now you see there is no error. It says you appear to have cloned an empty repository. So I did a git clone command with this HTTPS URL. It cloned in the repository. I provided the credentials. The credentials are provided only one time because I used a credential manager, which will store my credentials. And then cloning is done, and it says you appear to have cloned an empty repository. If I see my current directory, there is this directory created, skill upright demo. This is the Git repository, and you can see, oh my God. So there is nothing here in this directory, right? I can maybe add a file. I can say notepad, new file, and it opens a file. It says, do you want to create a file? Yes. Some text. I save it, and I close it. And you can see here, I created one file here called new file. If I do a git status, it says there is a new file here. Git add, new file, commit. I give a message also, like first commit, and then I can make git push. And it pushes, right? And if I go to this repository, and I go back to the repositories list, I see this repository, and the last modified is just now, right? If I click on this repo, now you see the contents of this repo, which is new file. So I created a new file here. I pushed it. And as you must have seen, the permissions for this repository and complete management of this repository is within AWS. I do not need to rely on GitHub or GitLab for my repository needs, right? So it's pretty assuring in governance perspective. Okay, so here we go. You can also use this GUI to create new file. You can upload a new file or create a new file. You can see the details, contents of a file. You can also edit a file and see everything. You can see the branches that exist on this repository. So there is only one branch, which is the default branch. You can change the settings of this repository. So the name, the default branch name, you can delete it if you're done with the repository. You can set notifications, right? You can create a rule that, hey, if there is any new commit in the repository, send an email or send an alert or things like that, right? So this is your code commit where you can put your source code, right? Guys, if you have any questions, I see there are some questions on the chat. I will not answer questions from the chat. I will answer questions from the Q&A section. Okay, thank you. So, and that's because it's very easy for me to track the questions. On chat, it's just not possible because there are so many messages. Okay, this is your code commit, right? Let's go to build, which is code build, right? And this build is nothing but a set of steps which you can execute for on your source code. And now here, let's create a build project. There are no projects as of now. Let's create a build project. And let's give it a name, skill upright build project. And then we can give more information like description, badging, like build is successful or not. So the state of the builds and things like that. I don't want to do anything here. First step is the source, right? The build will execute, but where will this source code come from? So you can choose AWS CodeCommit. So get my source code from CodeCommit, and you can immediately see the repositories available in this account for the code commit. So I can choose that, or you can choose some other resource. For example, if you have a repository on AWS S3, you can use that, or from GitHub or Bitbucket or GitHub Enterprise, right? Code build does not depend on code commit. So you can have source code repository from anywhere of these options. You can create a repository on GitHub and then connect to GitHub and then get your source code from there, right? But right now we are talking about AWS specific technologies. So let's stick to code commit and then skill upright demo. Then you can choose which branch you want to get the code from, or which specific tag or which specific commit ID, right? Um, you can see all the commits. So there is only one commit here. We are going to choose a branch and I'm going to use the master branch. If you have multiple branches, then those can also be seen here, but we have only master branch. So this is the Git source repository. You can add more information like clone depth and things like that. But yeah. So then the build, where do you want to build this? Right? Do you want to build on an EC2 instance or a Lambda instance? If you want to build on EC2 instance, which AMI you want to use? Do you want to use a AMI which is managed by Amazon or AWS, or you want to provide your own custom AMI, right? I say my own image. It's not actually AMI. These are Docker images. Okay. Then, for example, let's say the source code is based on Python. Yeah, let's say the source code is based on Python. So what operating system you want in the image, let's say Ubuntu, but then you have to specify which runtime you want, standard runtime, and the image. So there is a image, for example, standard 7.0. Okay, you can define more information like timeouts, build queue timeout, normal timeout, SSL certificates, VPC, what is the configuration of the servers on which this code build will happen, set environment variables, things like that. You can define everything, right? So you can do all those things. I'm not going to define anything else here. But then next step is, so first step was source code. So what is the build going to run on? The next step is the environment where the build is going to run, right? In which kind of machine, what is the environment there, what is the runtime there. And then later you have to specify what happens in the build. That's defined in the build spec. So either you can have a build spec file, which is a YAML file, and you can write your build spec or build specifications there, or you can write your command here itself, right? For example, if it's a Java-based code, then I can say Maven test or Maven package and things like that, right? So let's say maybe I will add more details here, but right now the build command will be something like this. I just want to run this command. Echo, this is the dummy build, right? But you can use a build spec file and write very complicated build steps. Okay. And then you can define artifacts. If artifacts are generated, what happens to them? So I can say, put the artifacts in Amazon S3. You can give a name of the bucket, name of the folder, and then what path, and things like that. Okay. You can also specify where do you want to see the build logs? Do you want to push them to CloudWatch? Yeah. So this is a build, and you can click on create build project. Maybe I did not give anything. So right now I'll say no artifacts, but later we can come back, or maybe some other day we can see in detail. Click on create build project, and it says type is required for environment. Let's see something missing. Environment. Let's see a type. Let's say no CloudWatch. Just give me a second. So, for all these steps to take place, uh, it has to work with other AWS resources, right? For example, it has to access the code commit. So for that, um, it should have correct permissions, right? It has to access the EC2 environment, right? So that it can create the servers and run all your installation or build steps. It may have to access S3 bucket if you want to put it somewhere. It may have access for VPCs, right? So there are a lot of access required. I am logged in as the root account, so I should have all the accesses. But let's say it says policy already exists. So let's do one thing. create another one. I'll be quick here. All right, so build project is now created. So if I go to the build projects, I can see this project now. And it says it uses this repository and some more details, right? I go here, I can see the complete detail here. So no builds have executed. And here are the details about what is configured here, right? And you can see the build spec is already generated. Based on my command, it generated the build spec. Anyways, so I come here and then I click on start build, right? I can manually start a build. So it runs this build here and you can see the logs. You cannot see the logs right now because I disabled CloudWatch. But maybe we enable it later and see the logs. And what it's going to do is it's going to clone the repository, run our build command, and that's it. Right? Build is successful. If you see, it is all the stages are completed, but we don't have any much details here. We don't have even logs because I disabled the log, the CloudWatch log. So next time what we are going to do is I'm going to edit this project configuration and just give me a second. All right. So now here, so I'm going to go to log, click on edit, and I'll say enable CloudWatch logs, update logs. And let's run a build again. Now you see it will show us build logs. And you can see here the log sentences, right? The log statements. So it is downloading the source, Git repository, and then changing the directory, which is the repository directory, and then run the command called echo hello from AWS. This is the output, and that's it. So here, instead of this running this command, you could have said Maven package or Maven test or pylint or whatever command you want to run on source code. And yeah, this is how you can do it. Now, we are already, I think, end of the time, but I can quickly show you if you go to pipeline, right? You can create a pipeline, and in the pipeline, you can do the same things. So you can give a name, for example, scale upright, pipeline version 2. You can use the new service role, for example, here, then click on next, and then you can choose your source code provider, right? Where is the source code? So I say CodeCommit, and the repository name is this one. Branch name is master. And you can say anything that happens on the source code should trigger this pipeline. Click on next. The build provider, what should be the build? And here you can choose the build that you have created. You can also add a Jenkins trigger, but you can say AWS code build, and I have created already a build here, which we executed just before this, right? And then run a single build from the source code. Click on next. And then where do you want to deploy? Do you want to deploy using a cloud formation, or do you want to deploy on ECS, Elastic Container Service, or you want to deploy from app config, or if you're deploying your application on Beanstalk, you want to do that. So you can choose all that stuff and deploy there. For example, then you can choose the region, application name, and then finally everything will be created for you. So now if you create a pipeline, the source code will be taken, it will be subject to build, and then you can deploy it. And then finally your application will be there in production, right? So these are the tools which will help developers immensely for creating their source code, for working uh, with the code and working in a team, and then deploying and delivering faster. So that's all I wanted to discuss. Again, the repositories and the builds, they are charged. For example, repository is charged based on how much data they use, storage they use. The builds and the pipelines, they are charged for how long they run for, right? Their execution time. So you have to keep those things in mind when you try to make use of these solutions. Okay, I can take questions now. Recordings, yes, recording will be available for you guys. You might receive an email for recording. CodeBuild doesn't support SVN. No, I think it is an industry standard now to use Git for your version control needs. And almost all the technologies exclusively support Git. There are technologies which support SVN, but there are very limited functionalities. How can I configure SonarQube to a project on AWS? You can set up a SonarQube server, and then in the build project build spec, you can define, Sonar scanner. You can run that, which points to the SonarQube server, and you should be good. Question, isn't it like we are using Git and GitHub, but only difference is we are using it on cloud? Yes, that's it. Any limit on number of parallel builds. There is theoretically no limit, but if you want to run more parallel builds in your build setup, you should use a more powerful machine, like maybe 8 CPUs and 16 GB of memory or things like that. That's the only limitation. Is this service chargeable? Yes, as I mentioned. As I mentioned, it is chargeable. What are the charges, for example? So if you see the source and you say getting started, right? You can look at the pricing for CodeCommit. So you have free tier, but then later, if you are not in free tier, then you pay 6 cents per GB per month. And 0.001 USD per Git request, so per Git clone request. Okay. And similarly, you can see, for example, for build, there are charges. So if you go here, so it depends on what kind of CPU and RAM configurations you have chosen. If you say 2 CPU and 3 GB of RAM, it will charge you this per minute, right? And things like that. So yeah. Okay, next question. While starting project, we used custom AMI and proceed further. So I set up the default AMIs, managed AMIs, but you can choose custom AMIs as well, right? As soon as your AMI is ready, we can use that. But for code build, actually it uses Docker. So it's not actually AMI, it's actually Docker image. Can I use all Git commands in CodeCommit? Yep, because in CodeCommit UI, you don't use git commands. You use git commands here when you clone the repository, so everything will work. Is there any free trial available? Most of the services are available as part of the free tier, which is available for 12 months. So you should explore that. Can I invoke pipeline from Jenkins? No, but you can invoke Jenkins builds from your pipelines. That can be done. How to decide computational power for a project? It just depends how much resources your builds require. Based on experience and based on past build executions, you may see that what you chose before is not enough, so you add more compute power. So it's all, based on how your builds are performing. How can I implement secure branches in AWS CodeCommit? When you mean secure branches, what do you mean? Permissions for branch specific permissions? So Akshay, do you mean branch level permissions? So you can create uh, rule templates, right? And you can specify who can push to which branches, then pull requests and things like that. So that can be done. All right. So now it's time. So we had a very good high level overview. Let's see, in the next time I can get into more details of maybe code commit or code build or code pipeline. Right now, we just don't have enough time. So hopefully this is enough for you to start your further learning. You can create a free account and start exploring here. And yeah, so thank you. Thank you for your time and all the best for whatever you are doing right now. And hopefully I see you later. Thank you and bye.
Thanks, Amit.